Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's the only way you can help your friends discover my channel. And of course, if you like what I'm doing, to keep me refreshed, inspired, and energized, don't forget to subscribe. This problem was already solved by three moment equations and slope deflection equations. Let's verify the answers by moment distribution method. So determine the internal moment at B. E is constant. So to prepare for the fixed moments, let's have a strip here. Let's call this X here. So this is differential P, which is equal to 24 dx. So fixed moment AB is equal to negative integral of 24 dx, quantity 1 plus x, then 6 minus x square, 5 minus x square rather, over 6 square, because this is 5 from this point to that point, and we already assigned this as x, so this is 5 minus x, over 6 square, 0 to 3. So fixed moment AB is negative 54.5 kilonewton meter. Likewise, fixed moment BA is the same integral, positive 1 plus x is now square, 5 minus x raised to 1 over 6 square. So it is 41.5 kilonewton meter. Fixed moment BC, there are two loads. So for the couple, it is, because it is clockwise, so it is 120 over L square, 4.5 square, B, MB, which B is 3, 1.5 plus 1.5, then quantity 2L minus 3B, 2 times 4.5 minus 3 times 3. Then for the 18 kilonewton load, so negative of 18 times A, which is 3, B square, which is 1.5 square, all over L square, 4.5 square. So fixed moment BC is negative 120 times 3 over 4.5 square, quantity 2 times 4.5 minus 3 times 3, but this is 0, so that's just 0. Then minus 18 times 3 times 1.5 square, all over 4.5 square. So fixed moment VC is negative 6 kilonewton meter, while fixed moment CB is positive 120 times A, which is 1.5, all over 4.5 square, quantity 2L minus 3A, 3 times 1.5. Then plus 18 times 3 square times 1.5 over 4.5 square. So it is 52 kilonewton meter. Let's now have the tabulation. By the way, the stiffness of member AB for computing distribution factor for BA and BC is, because A has 0 moment, so it is modified by multiplying 3/4 of its relative stiffness. 3/4 of 1.5, because the moment of inertia is 1.5 over L6. So 3/4 of quantity 1.5 over 6. So that's why it is 3 over 16. Same is true for BC. C has 0 moment. Therefore, the stiffness is modified. 3/4 of 1 over 4.5. 3/4 of 1 over 4.5 is 1 over 6. So let's now tabulate and put the distribution factor at A, because it is spin, so it is negative 1.0. 1.0, but I put negative here. That's my technique, so that you don't worry about changing the signs after distribution. This is negative 3 over 16 all over 3 over 16 plus 1 over 6. That's why negative 9 over 17. Therefore, for BC, it is negative 8 over 17, and for C, negative 1. Fixed moment should be placed here. Negative 54.5, 41.5, negative 6, then 52. Then let's distribute. So negative 54.5 times negative 1 is 54.5. And that's already 0. We expect moment that is 0. So let's lock that later finally. So quantity 41.5 minus 6 times negative 9 over 17 is negative 18.794. Quantity is 41.5 minus 6 times negative 8 over 17 is negative 16.706. 52 times negative 1 is negative 52. So let's lock A and C. Finally, the moment 0. Moment at C is 0 also, final. Then carry over. So as same as before, we don't need to carry over half of negative 18.794 anymore to A because it is already finalized. So only 54.5 divided by 2, put it here, 27.25. Same issue, we don't carry over half of negative 16.706 to C because C is already finalized and the moment there is 0. So half of negative 52 carried over to B, which is negative 26. So these are the new unbalanced moments at B, and the net unbalanced moment would be the sum of these moments here. So distribute. Quantity 27.25 minus 26 times negative 9 over 17, put it here, is equal to negative 0.6618. Then quantity 27.5 minus 26 times negative 8 over 17, put it here, negative 0.5882. Since we cannot carry over half of these values to the ends of the member, and the ends of the member have been locked already and finalized, so no moment can be carried over to joint B anymore. So that means we have to lock joint B finally. So adding the moments, we have 0 at A. Here it's 0 also at C, and negative 49.294, positive 49.294. So that means moment at B is negative 49.294, which confirms our answer as in three moment equations and in slope deflection equation. So MB is negative 49.294 kilonewton meter. So that's it for this problem.